Now, as I mentioned in the first video on this section of the text, our sum and difference formulas can also be used in helping us to verify trigonometric identities as well as solve trigonometric equations. And that's what you'll see in this video here. All right, in this problem, we are told to verify the following identity. Verify the following identity means make the left-hand side equal the right-hand side. We don't want to touch the right-hand side. Let's work with the left-hand side only. Well, we notice that we have a difference. We have subtraction inside of our tangent function. And that tips us off that maybe we want to use our difference formula for tangent. The tangent of u minus v is equal to the tangent of u minus the tangent of v divided by 1 plus the tangent of u times the tangent of v. Now, in this case, our u is going to be this quantity pi over 4, right? We can treat that as our u. And our v from the formula is going to be this x, right? It's just the first term minus the second term. So plugging into the formula, we get the tangent of pi over 4 minus the tangent of x divided by 1 plus the tangent of pi over 4 times the tangent of x. And the good news is we can evaluate the tangent of pi over 4. Go to your unit circle and find the angle pi over 4. Tangent means we take the ratio of the y-coordinate divided by the x-coordinate, and you will find that the tangent of pi over 4 is equal to 1. All right, so we can replace each one of these with a 1. Well, what does that give me? That gives me 1 minus the tangent of x divided by 1 plus the tangent of x, and that's what we were looking for. All right, so we use that difference formula for tangent to prove our identity. That is what we wanted the left-hand side to equal. Let's try one that's a little bit harder here. Verify the following identity. Cosine of x plus y times the cosine of x minus y is equal to cosine squared x minus sine squared y. So again, make the left-hand side equal the right-hand side. Well, notice we have these two quantities, and inside of each quantity, we have, in the first one, addition, and in the second one, we have subtraction. So we can use our sum formula for cosine as well as our difference formula for cosine. Rewriting our first portion of the expression, cosine x plus y, that would be cosine x cosine y minus sine x sine y. And rewriting our second portion, we would have cosine x cosine y plus sine x sine y. Again, here we have our first grouping, cosine x cosine y minus sine x sine y. That's from our first grouping. And we have cosine x cosine y plus sine x sine y from our second grouping. Okay, it looks a little bit nasty, but the good part about this is that they are actually conjugates of each other. All right, they are conjugates, and we are asked to multiply, this means multiply, our two conjugates. And the good news about multiplying conjugates is that the outer and inner terms are going to add to 0 when we FOIL them. So that's going to make our life a little bit easier. Let's begin to FOIL. Cosine x cosine y times cosine x cosine y. Those are my first terms. Well, you might notice they're identical. Cosine x cosine y times cosine x cosine y. That's going to give me a cosine squared x cosine squared y. My outer terms and my inner terms are going to add to 0. And I've got a negative sine x sine y times a positive sine x sine y. Well, the sine x and the sine x gives me a sine squared x. The sine y and the sine y gives me a sine squared y. That's going to be a minus sine squared x sine squared y. So we multiply them together. We get cosine squared x cosine squared y minus sine squared x sine squared y. We're getting there. Let's take a look at what we want in our final answer. We want cosine x's and sine y's. Here I've got a cosine x. That's a good thing. But here I also have a sine x. That means I want to rewrite this portion, this sine x, in terms of cosines. And we can do so by using our Pythagorean identity. Remember, the sine of sine squared u plus cosine squared u is equal to 1. That means I can replace this sine squared x with a 1 minus cosine squared x. Similarly, I want sine squared y in my final answer. That's good, I can keep that sine squared y, but I need to rewrite this cosine squared y, again using our Pythagorean identity. I can replace cosine squared y with 1 minus sine squared y. So we've got cosine squared y times 1 minus sine squared y minus 1 minus cosine squared y times sine squared y. Let's now do out the algebra. Let's multiply all of this through. Well, that gives me cosine squared x times 1 is cosine squared x. Cosine squared x times negative sine squared y gives me a minus cosine squared y sine squared y. A minus 1 times sine squared y gives me a minus sine squared y. A negative 1 times a negative cosine squared x is positive times sine squared y, cosine squared x, sine squared y. Positive cosine squared x, sine squared y. All right, so we just did our algebra and distributed. The cool thing here is that I now have some like terms. I've got a minus cosine squared x sine squared y here, and a plus cosine squared x sine squared y here. Well, those are opposites of each other. When I add them together, we end up with 0, and I am left now with cosine squared x minus sine squared y. And that is my final answer. All right, so another example of using our sum and difference formulas, in this case, to verify identities. Now let's talk about using the sum and difference formulas to help us in solving equations. This says find all solutions of the equation in the interval 0 to 2 pi. We have the sine of x plus pi over 3 plus the sine of x minus pi over 3 is equal to 1. Well, inside of each one of these trig functions, I have a sum or a difference, which means we should probably look at using our sum formula for sine and our difference formula for sine. We can use the sum formula for sine x plus pi over 3 and rewrite the expression as the sine of x times the cosine of pi over 3 plus the cosine of x times the sine of pi over 3 plus, and now we can use our difference formula for sine for our second grouping. The sine of x times the cosine of pi over 3 minus the cosine of x times the sine of pi over 3. And all of that is equal to 1. So that helped us because now we just have x's inside of these unknown trig functions. Okay, well, what do we recognize? Here I have a positive cosine x sine pi over 3, and here I have a minus cosine x sine pi over 3. Those quantities are going to cancel out. That leaves me with a sine x cosine pi over 3 plus a sine x cosine pi over 3. Well, those quantities are the same. If I have one and I add another, that gives me 2 sine x cosine pi over 3 is equal to 1. Now, the cosine of pi over 3, we can actually evaluate this using our unit circle. We find the angle pi over 3 on the unit circle, look for the corresponding x-coordinate. The cosine of pi over 3 is 1/2. Well, 2 times a half, those are going to multiply to just give us 1. And we are left with sine of x is equal to 1. Now that we have isolated the trig function, we can go to our unit circle and locate the angle between 0 and 2 pi that has a sine value of 1. Now notice we are only looking for answers in this particular interval. All right, so we don't have to tack anything on. Well, what angle has a sine value of 1? That's going to be pi over 2. X equals pi over 2 is our solution. Let's try another one. The cosine of x plus pi over 4 minus the cosine of x minus pi over 4 is equal to 1. So similar to the last problem, except now we're going to have to use the sum and difference formulas for cosine. All right, here they are. We can replace cosine x plus pi over 4. That's going to be cosine x cosine pi over 4 minus sine x times the sine of pi over 4 minus, and notice I've put this entire quantity in big brackets because it's very important to pay particular attention to distributing negatives. We are subtracting this entire quantity. So this entire quantity here in the numerator correlates to this entire quantity that I put in the brackets, minus the cosine x cosine pi over 4 plus sine x sine pi over 4. All right, so that's using our sum and difference formulas for sine and cosine. Let's take a look and see if there isn't anything that's going to simplify or cancel out. We've got a cosine x cosine pi over 4 minus a cosine x cosine pi over 4. I could subtract those right off the bat if I wanted to. Okay, a minus sine x sine pi over 4 minus another sine x sine pi over 4. So I can combine those as well. Now, another option is to actually evaluate the cosine of pi over 4. We know what the cosine of pi over 4 is. We can go to our unit circle and find it. The cosine of pi over 4, well, that's root 2 over 2. And if I plug in root 2 over 2 in for the cosine of pi over 4, and the sine of pi over 4 is also root 2 over 2. Cosine pi over 4 is root 2 over 2. Sine pi over 4, root 2 over 2. I end up with root 2 over 2 cosine x minus root 2 over 2 sine x minus the entire quantity. Again, that's our grouping, big bracket. Keep track of those negatives. Minus root 2 over 2 cosine x plus root 2 over 2 sine x. And here we can now see the root 2 over 2 cosine x minus root 2 over 2 cosine x. Those are going to subtract to 0. So you could have canceled them out beforehand if you wanted to, if you recognize that. All right, and then we have a minus root 2 over 2 sine x minus a root 2 over 2 sine x. Well, what does that give me? I've got a minus 1 of a root 2 over 2 sine x minus another 1 of a root 2 over 2 sine x. That gives me a minus 2 root 2 over 2 sine x is equal to 1. Notice that our 2's, we can cancel those out, leaving us with negative root 2 times the sine of x is equal to 1, meaning that the sine of x is equal to negative 1 over root 2, and rationalizing our fraction here by multiplying by root 2 over root 2, we get sine of x is equal to negative root 2 over 2. And now that we have isolated the trig function, all right, we can go ahead and go to our unit circle. We find the angles on our unit circle that have a sine value of negative root 2 over 2, that have a y coordinate of negative root 2 over 2. Well, that's going to give me 5 pi over 4 and 7 pi over 4. And those are my solutions on the interval 0 to 2 pi. All right, so sum and difference formulas, lots of different applications. Here you have verifying identities and solving trig equations.